out from the strength of the fluorescence how bright the centre of the galaxy was, it was 1,000,000 times brighter. So had the Victorians, and whether you call them, you know what I'm, people 150 years ago been doing X-ray astronomy, before X-rays were discovered, then they would have found a very bright source in the sky. Okay, it would have been the centre of the galaxy. And we know it was bright from 90 years ago to at least 500 years ago, because you could look at other clouds. It turns out somehow it's switched off, and we don't know why.
So according to your feedback scenario, so is it possible to see that if one galaxy used to be an AGN before? Possible? I'm looking at the feedback.
Yeah. Is it possible to see that a galaxy was active? About the only way you can do it is to see that there is a black hole in it, and so it was active, right? We've got a 4 million solar mass black hole in the centre of our galaxy. It will have liberated 0.4 solar mass c squared of rest mass energy, okay, which is a hell of a lot of energy, and by my calculation, it's more than 100 times enough to unbind the bulge of our galaxy. It hasn't done so, presumably because the stars have formed earlier, but it's an enormous amount of energy. So it's difficult to piece everything together, but I'm sure as we take more observations, most of the quasar era was back redshift 2 when all this activity was going on, using instruments like ALMA and so forth, which compare inside all the gas clouds around quasars. We've already got evidence that these gas clouds are streaming out. I think we may be able to piece things together to get a picture, a clear picture of exactly how the feedback is operating. At the moment, it's based upon me saying that there's a lot of energy, there's a lot of momentum from the radiation, and also by evidence in some cases you can see something happening.
Can you comment on the first quasar that occurs like Z equal to maybe beyond 7, and
yep.
What specifically what I'd like you to comment is the birth of this kind of supermassive black hole in such a short time.
Yeah, sure. You're now taking us right to the frontiers of part of black hole work, and that is that, for example, as you said, redshift 7, the most distant quasar we know is at redshift 7.08. It was found by some colleagues of mine, and it's a few billion solar mass black hole, presumably in the center of this quasar. Curiously, when you take a spectrum of the quasar emission, which is coming from gas swirling around it in the optical band, it's got a spectrum which looks identical to quasars at redshift 1 to 2. That's a very important clue on something that nobody understands. But you're asking how it formed. We don't know is the basic answer. We think that quasars form, we think that black holes form by collapsing stars. The most massive star maybe that is likely to collapse is around 100 solar masses. Maybe you can start off with 100 solar mass black hole. You can then let it accrete. Okay, if you let it accrete, we think there's a maximum rate at which it can accrete. The maximum rate is basically infall, gravitational infall is counteracted by the radiation coming out, the radiation pressure out, acting on the electrons, gives a limit, which is called the Eddington limit, which means the doubling time for the mass, it's going to grow exponentially, is around 40 million years. And you find it's very difficult to grow a billion solar mass black hole, to grow a billion solar mass black hole in the time that you think is available. You can just about do it if everything's working in your direction. It's a puzzle, and it's something that we don't understand. Some people argue that you can overcome the Eddington limit. I'm skeptical myself. Or maybe, and there are things called quasi-stars that some people have proposed, and that is you can get very large clouds of gas which just collapse directly into a black hole. Again, I'm skeptical about that, but it's very much an active area of research.
Okay, we have one last question.
Okay, in the Galactic Center, you said 500 or 600 years ago,
Yeah.
it was millions of bright out.
Yeah.
And you show also the stars around the black hole.
Yeah.
So question is, those stars have evidence to be radiated by such a strong X-ray?
Good question. I don't think so. I mean, there are spectra of those stars. They're very massive stars. They've got very high luminosities. I've not heard, let me say, I don't know if anybody's checked. I've not heard that there's anything dramatically peculiar about them. I dare say, though, I was once involved in a project where we did irradiate stars, and it's actually very difficult, even with that luminosity, to make a lot of difference to the stellar surface, okay, because the star is so dense, okay. But it's worth checking. I'll do that. Thank you.
Okay, thank you. Let's thank our speaker again.